Welcome to this explainer. Today, we're breaking down Ecoloop. This is a predictive waste-to-energy orchestration platform engineered specifically for the Avinya 2026 Prakriti Eco-Innovate Challenge, tackling problem statement 9. If you're on the judging panel today, get ready because we're looking at a system that fundamentally shifts how we manage municipal waste. We're talking about transforming it from a massive logistics headache into a highly optimized, decentralized energy asset. So let's just dive right into it.
Listen, here is the fundamental flaw of the status quo. Waste collection today is entirely reactive. The current model is literally just wait for a bin to get completely full and then send a truck, right? This fullest bin first approach is exactly why municipalities are constantly struggling with totally inefficient routes, unnecessary trips, excess vehicle emissions, and of course those gross overflow events. You're constantly reacting to a problem instead of predicting an opportunity.
So our core engineering thesis flips this entirely on its head. Simply put, don't optimize for full bins, optimize for resource value. Because waste isn't actually the problem here, uncertainty is. We have to start treating organic waste not as garbage, but as a highly time-dependent resource. We are shifting the entire operational goal from basic transportation logistics to actual biological resource recovery.
Well, how do we actually make that happen in the real world? Ecoloop operates on a tightly connected, six-step architecture. Sense, predict, optimize, recover, reward, and learn. Now, this isn't just a standard linear chain, it's a closed-loop learning system. Every single step feeds critical data right back into the next, which continuously refines the network's efficiency and its overall output.
Step 1 is capturing the actual ground truth data, and we do this through what we call EcoSense. We are definitely not relying on guesswork here. Ecoloop uses low-cost ESP32 IoT sensors for ultrasonic fill sensing, paired up with AI computer vision right at the household level to classify the waste. The system literally analyzes the waste and decides, okay, this is a vegetable scrap with 94% confidence, let's route it to bioenergy. Or, wait, this is plastic, keep it out of our digester. We are separating incredibly valuable organics from contaminated waste right at the source.
And what's really fascinating is how we handle the predictions. We aren't just making a static AI guess and hoping for the best. Ecoloop runs a continuous machine learning loop where our predicted fill levels are ruthlessly validated against actual, real-time IoT data. By constantly comparing the AI forecast with the actual IoT ground truth, the system actively minimizes its forecasting error. We're targeting an optimized mean absolute error of X and a mean absolute percentage error of X. So the model actually learns from its mistakes and improves its accuracy every single day.
Once we know what waste is coming, we calculate its true worth using our bio-yield model. We use hard biological constraints to translate predicted clean feedstock into a scientifically grounded biogas range. To put that into perspective, imagine a collection zone that has a ton of mass, say 320 kilograms, but its purity is sitting at an awful 58%. That yields a surprisingly low biogas range. Meanwhile, another zone might have almost half the mass, but at 93% purity, it produces significantly more biogas. A naive old-school system would blindly send trucks to the heavier zone. Ecoloop knows better.
Section 1. Bio-aware predictive routing, the mathematical heart of Ecoloop. The absolutely crucial point lies in our multi-objective OR tools optimization model. We are simultaneously solving for multiple constraints under the hood. We mathematically minimize travel distance, fuel and CO2 emissions, overflow risk, and the total vehicle count. But the real kicker is that final piece. While minimizing all those operational costs, we explicitly maximize recoverable biological value. This proves we are dealing with a rigorous mathematical optimization problem here, not just throwing around some AI buzzwords.
I absolutely love this phrase. The route knows what the waste is worth. Just think about the power of that for a second. The system dynamically prioritizes high-yield organic zones rather than blindly dispatching your fleet to pick up heavy, low-value mixed waste. Is an entirely new paradigm for municipal logistics. Let's think about a direct comparison. In a standard, naive routing scenario, 3 trucks are sent out prioritizing the highest fill levels. They end up picking up a lot of heavy, highly contaminated garbage. But with Ecoloop, you take those exact same 3 trucks, put them on an optimized schedule prioritizing the highest resource yield, and the results are night and day. By anticipating biological value, we drastically improve the efficiency of the entire fleet. We are collecting the very fuel that powers the decentralized energy network, and we leave the low-value waste for secondary, much more efficient bulk runs.
Section 2.
Validating the impact, experimental evidence, and simulated outcomes.
Now here is the raw data actually proving the math. By comparing a standard baseline directly to Ecoloop, you can see exactly how predictive optimization works in reality. We calculate a reduction in required vehicle kilometers by X%, drop fuel consumption by X%, and even reduce the total number of trucks needed by X%. But honestly, most importantly, we eliminate overflow events by a full 100%, while simultaneously boosting organic yield by X%. The math simply doesn't lie.
And when you take all those logistical savings and translate them into sustainability metrics, you capture the true climate impact. This system demonstrates a precise reduction of X kilograms in avoided carbon dioxide emissions. It's a massive, mathematically measurable win for the climate.
Section 3. The behavioral loop and digital twin, scaling the solution.
This is where the human element, EcoLeague, and the EcoScore comes into play. Now, what's really important to note here is that this community competition is rigorously based on actual environmental outcomes. We are completely avoiding vanity metrics here. You don't win just by clicking a button in an app. Your score is weighted. 35% is based on segregation accuracy, 25% on organic recovery, 20% on reducing contamination, and so on. We are measuring actual physical improvements in the waste stream.
And of course, those outcomes tie directly to eco-rewards. This system converts high environmental performance into highly tangible benefits, things like campus printing credits, utility discounts, or local business vouchers. And brilliantly, we use community multipliers. If an entire neighborhood improves its source segregation together, everyone's rewards multiply. It naturally incentivizes collective, community-wide behavioral change.
To prove how all of this connects, we've built the EcoTwin digital simulation. This interactive dashboard invites you, the judges, to step right into the driver's seat. You can tweak baseline inputs, like the number of households or the community segregation rate, and instantly observe how the system mathematically responds. You will literally watch the routing engine adapt, see the CO2 emissions drop, and watch the biogas generation estimates update in real time. It is a live cause and effect demonstration of the entire architecture.
So bringing it all together, Ecoloop relies on a robust, closed-loop pipeline, sense the actual ground truth, predict the biological value, optimize the routing logistics, and recover the absolute highest quality feedstock. It is a highly scalable, mathematically grounded solution built exactly for the demands of decentralized energy networks like the ones required in Problem Statement 9. I want to leave you with this final, incredibly powerful paradigm shift. We don't just collect waste, we predict its value. By treating uncertainty as the enemy and organic waste as a vital resource, Ecoloop is ready to completely redefine municipal logistics. I hope you found this explainer as fascinating to explore as it was to share with you all. We are incredibly eager for the judging panel to see the live prototype in action. Thank you so much for tuning in.